Good afternoon, and thanks to INS to give me this opportunity. I'm feeling some goosebump because of some unknown fear that I'm not used to, but more the opportunity I will get, slowly I will get used to it, and this is coming just because of the natural human instincts. As such, we all humans as a genetically evolved to perceive fear, and matter of fact, not only human, every animal as such is evolved because they once perceive a fear, they operate in flight or fight mode. Here we are talking this radiation risk which cannot be perceived by the normal human being, and that is the required or help which needs to be taken. That is where the regulator's job comes. And I'm going to deliver this talk on emergency preparedness and response. What is the current position as on today, and what are the challenges ahead? This slide basically gives you an overall standing as of today, what we are doing. Mission of AERB, that is allowing use of radiation and its application, nuclear energy, without undue hazard or risk to the public and the environment. Now, radiation or facilities pose certain risk, not only under potential accident conditions, but they do pose risk during their normal operation. So that's what the debate or questions are there about 1 millisievert or so, that we'll see that. Now to achieve this, we are having nuclear safety objective that operate the facility safely, accidents to be prevented, and if accidents cannot be prevented, their probability to be minimized, and if accidents do happen, releases to be minimized, and if releases do occur, have necessary emergency preparedness and response to attend to it. Now to do that, goal of emergency preparedness, that you should have necessary infrastructure in place for effective response. And then goal of emergency response, that apart from various other things, prevent severe deterministic effect, and second is reduce the risk of stochastic effects. This all is achieved through this elaborate, complex approach, defense in depth, what we call, that is ensuring barriers in the pathway of release of activity are ensured by multiple barrier or engineered measures. Those are either by design, by passive in nature, by active component, and with all this approach put together, we operate our facility safely. But because of external events or because of any internal failures and all, sometimes situation can deteriorate and it can basically go beyond your control. For that purpose, there are design basis engineered safety features to handle these design basis accident, and further multiple failure if it is occurring, we are having severe accident management guidelines and all. That is as part of level 4 defense in depth. That is where we put all our effort to control and confine the reactivity. And the last level is defense in depth, that is level 5, that in spite of all our effort and all, activity do go out of your building or containment, then you need to have your emergency preparedness and response in place. Now, morning we have discussed about that we need to achieve net zero. We have to rapidly expand our nuclear power program, and then to do that, we need to introduce technology, diverse technology, and then of course with the help of JBP, PPP and all. Now to do all these things, the fundamental safety function which needs to be achieved is control of the reactivity. Second is in our reactor, even if you are able to safely shut down the reactors, you need to continuously remove the decay heat. And The third function is that confinement of activity, and finally control of the discharges. So to achieve, we need to have a robust emergency preparedness and response framework. This is what I'm going to talk is level 5 of defense in depth, wherein you need to place emergency preparedness infrastructure to mitigate the effects. Of course, level 1 to 4 is being managed at the site by the utility. Now, to achieve this framework, we should have a clear and consistent regulation. That is, the regulatory body is empowered to bring out the codes and guides which needs to be in place, and the guides helps to meet these requirements. Resilient oversight mechanism, it is not enough that you stipulated the requirement and given the guidance. You have to ensure that to meet those things, the things are in place and they need to be checked time to time. Comprehensive emergency preparedness framework, that means code, guides, oversight mechanism. You need necessary infrastructure at the site, of the site, for taking necessary response action timely. And of course, it is not between the utility and the regulator. You need to have engagement of all stakeholders, all response organizations or coordinating agencies. The interfaces should be clear. The language or what basically they communicate, that should be clear. And then with coordination of other agencies, that part of national emergency preparedness and response. Initially, when this emergency preparedness and response thing was there, that was at the local level, district level, and slowly because of 2005 Disaster Management Act and all, the whole hierarchy is developed where the engagement is from top to bottom. Now, to achieve this, the first reg doc for the EPR, that is the codes and guides which we need to develop. There are existing codes and guides. They need to be continuously updated, taking into account international guidance which is available from the international events which has happened, like Fukushima, which has given a very important with respect to decision making, the importance of the time transaction, and of course the GSR Part 7, it is a kind of a GS general safety requirement given by this. And because of the national requirement, Disaster Management Act, and then whatever the lessons we have learned from our exercises. So from bottom to top approach, that we worked on the various documents on these emergency action plans, protection strategy, EPR, then guidance document on the emergency exercises, and then we have evolved our regulatory code. So right now, requirement for management of nuclear and radiological emergency is in place, and the corresponding guidance document, NRE 1, 2, 3, one is with respect to emergency at nuclear facility, another is with radiation facility, and third is with the transport accidents. There is an institutional framework, management of nuclear emergency is available. At the local level, your site emergency director, then response officer and incident commander is the implementation of protective actions in public domain. And then state level agencies are there, and the national level. At the national level, under DAE, that CMG DAE basically coordinates any infrastructure, any requirement with the help of MHA or is required is basically facilitated through CMG DAE. Now, role of these various stakeholders or various agencies at state level, district level or national level, it also depends upon in which phase of emergency I am having. In the initial phase of emergency where the knowledge is limited with the site director and the local, so early phase of emergency is locally managed, where you need to take quick and timely decisions with respect to of protective measures in public, and they are based on certain observable at the facility or certain observable of the site. Based on that, certain decisions has to be taken in time. Intermediate phase is the phase where now reactor is under control, the discharges has more or less ceased, there is no further, but then contamination do exist. You need to reassess whatever the decisions which you have taken. You may roll back some of the decision, you may expand the scope of the things. Slowly this emergency exposure situation transitions into the existing exposure situation. Further follow-up and post-accident cleanup is taken. Of course, during all these phases of exercise, emergency, you need help of not only the station and offsite, you need a lot of responders, public domain, emergency workers, and their safety is also equally important. Key areas for robust EPR, that when I say hazard, how we perceive and all, that is a hazard assessment. Question is that, what is a reasonable hazard assessment? What is the level up to which I want to analyze? Whether particular accident is ruled out by design or by probability, by active components and all. Infrastructure for emergency response on-site and off-site, that accident progression beyond design basis, that is called design extension conditions. If we need to mitigate its releases and all, what are the arrangement at on-site? If we need to mitigate and continue to observe, what are the releases which is possible to take place and what are the infrastructure required off-site? Now, in order to have a emergency plan and infrastructure in place, I should have a fair idea what is the kind of impact from a particular site or facility is there, and I need to prepare accordingly. So that emergency planning zones and distances are required to be established for a particular technology at site, and the most bounding calculations for a limiting design needs to be in place. Apart from this, we need to have a detailed EPR plans in place so that during emergency or during exercises we follow this for an effective response. Emergency exercises are carried out to test all the arrangements and their effectiveness. And then response framework for management of nuclear emergency. What is the role and responsibilities of individual in this emergency response framework? How well it is going to work out and be effective, it depends upon how well the individual as per their responsibility knows and they get activated for their role to play. Now these are the things which is fixed, which we can work out, but there are certain dynamic things during the progression of the accidents, and we need to clearly identify classification, notification and activation of response. Deteriorating condition in the plants can well guessed by the operator. He also understands what are the systems, how they are degrading, what is the likely timeline within which the reactor or meltdown or event will go. But release probability, what path or barrier give ups, that is the most uncertain. So classification, notification and activation are the most important point, wherein the timely information to go to the all stakeholders and responder so that they can prepare themselves for effective response. Now, even though everybody knows what to do, the question comes justification, optimization and reference level. In Fukushima, many times it is said that there are actions taken which was not warranted and they caused more harm than good. So these optimization and reference level, yes, there were certain decisions taken in Fukushima based on precautionary action in a particular directions and all. They were justified, but if happens to be in a direction where the residents are there, potential of the doses and all, that also needs to be seen. Non-radiological consequences, apart from that, the radiation risk which poses, you need to also concentrate the other risk factors, especially moving the patients and all, and they are already under this stress conditions. And then with this, we need to work out a protection strategy. So this needs to be closely worked out with the district responders as well as the station authorities. It is not good enough that a certain decision is taken and evacuated. Overall, this thing has to be holistically approached. Now, first part is the hazard assessment, that identification and all, what are the different possible accidents as per the safety assessment. We carried out depending upon various postulating, initiating events and all, what are the source term for external event as well as the internal event. Then evaluation of inventory and releases, ultimately what you need, what is the material at risk, and what is the amount which is likely to go out in public domain, its chemical forms and all. Then assessment of the distribution of radioactive releases, in what form it is going, assessment of the consequence. Now, severity of the accident does not lead to the severe consequence. The prevailing meteorological condition at the point of the progression of the accident and corresponding wind directions and all, both put together gives the consequence in public domain. So we need to kind of establish both assessment of the source term and the dispersion thing. Information on time frames and effectiveness of possible protective actions. The response actions required in the very early phase, especially when there is a plume which is going out, the inhalation doses which are there. Subsequently, there is a deposition if public is going to be continued to stay there. What are the possible accumulated dose and what are the actions which you need to take? And determination of emergency planning zones and distances. I will come to that. What are the different zones? What are the kind of accident this? Now, if you see this side, IC and EL are the documents and policy which needs to be in place. That plant operator needs to understand the initial conditions. They need to take intervention, correct the things, and as the thing progresses, that EL actions level which needs to be seen, and if found, then they have to declare the emergency classification. Source term. Now, in my assessment during the analysis time, I might have used the conservative estimates and all and calculated the bounding values. But during actual progression of the accidents, we have to see what is the scenario, what is the timeline, and based on that only certain decisions. So peacetime calculation for safety assessment, planning purpose is a different thing, and in case of accident, in the real time, it is a different approach. Protection strategy, you have to work out based on the population distribution, the non-radiological hazard, and planning and resource for effective implementation. That means all your planning also to be ensured that the necessary infrastructure with respect to iodine tablets, with respect to a number of emergency responders, what are the actions which you need to be take place, they are in place. And of course that EP zones which you need to declare. Infrastructure at on-site, right now from the main control room they operate, plant emergency control centers on-site, and then communication network should be robust, where and as and when you decide or indicate or notify, the all stakeholders, all the responder coordinating agency gets notified so that they can also start preparing for their response. This also needs to be backed up by this. Maybe reactor not habitable, you need to have in place instrumentation data management system, on-site emergency response facilities, continuous habitability of the plant operators when they are manning the things. It should not become near the site it is not habitable or they are not manageable. Safety parameter display, important parameters with respect to the healthiness or the integrity of the reactor or the containment that needs to be observed. And finally, the decision support system. It is a system where based on potential source term, you estimate what is likely consequence in public domain, what are the actions which are required. It is based on the predictive weather conditions collected from National Medium Range Weather Forecast and the predicted source term from the plant. There is another system support for this. There are monitors installed around the facility which helps them to back calculate what was the releases occurred and then realistically diagnose the things. So in the early phase of the accident, this decision support systems helps what are the possible areas and where they need to concentrate and take actions. But post-accident, when intermediate phase is there, you can have an elaborate calculation mapping about the contaminations and then work out what are the short-term, long-term doses and then take appropriate action. Infrastructure off-site is taken care by the district administrations and off-site emergency support center, emergency operations center, FOC, incident command post, shelter place. Once communicated about a certain decision to the district authorities, they need to take action in public domain, taking into account holistic approach, again causing good rather than harm. Now, PAZ, UPZ and IPD and ECPD, these are numbers to be established in the initially, and these are the distances where you need to take actions as a precautionary or the initial phase, and ICPD and EPD are the things where you have time. Now, question is that what is the reasonable accident for which we should postulate these things? If some claim comes that my technology is well proven and all, I don't require, there is no such scenario. But as a level 5 of defense in depth, I said that with all failure put together, now there is a likelihood of activity going out. Then he says that my probability of accident is not that high, whether we need to put it there. So that is a kind of a challenge which we need to address. EPR plans, now taking into account all these things, we are having plant emergency, site emergency and off-site emergency plans of the station utility. Then off-site emergency plan prepared by the local authorities. These are reviewed and then approved plans, and regularly we carry out the exercises. Now tabletop exercises is being conducted at the site, and earlier approach was fix accident, fix source term, fix direction, fix affected people, where you take this. Now, in order to assess the ability or decision-making ability of the plant or district authorities and all, it is now made dynamic. It is inject-based, that a priori information is not made available to the utility or the district authorities and all, and based on the injects, they need to basically deduce how the accident progressions are taking place and take appropriate actions. Now, tabletop is checking the decision-making ability of the plant personnel. Integrated command and control response not only checks the ability of decision-making, but it also checks the coordination between various agencies. What are the information flow, the timely information, whether it is flowing between the various agencies or not. And then field exercise and demonstration. Again, it is now coming into the district domain. They need to keep on updating themselves by carrying out this. There is an elaborate time-wise program is given, that tabletop every 2 years, field and demonstration every year covering 2 sectors. In 8 years, they are covering complete area. And then ICCR in every 3 years, we need to carry it out, and the relevant agencies are identified. Now we can see that this is the kind of a complex picture where information has to flow from one agency to another for effective decision making and all. This is going to work only when we are having all infrastructure required to meet the effective response, and people understand their role and the importance of time and availability of necessary infrastructure in place for the communication. Challenges ahead. Brownfield site, we are looking towards urban and semi-urban sites, population density and all. Yes, I can claim that my plan is good. I will be able to take effective action. This is how I am going to control the individual risk. Yes, you take decisions and all. So that means I am licensing a facility which is having only a short-term concern, and that by an emergency response I can handle. But if there is a contamination all around and continuous habitability of the people is going to be limited, that also needs to be seen. So when we are licensing the facility, you should not, as per our siting code, deck bay criteria, that is a design extension condition under meltdown, it should call for no permanent relocations, or even if it is there, it should be limited in time and space. Mix of NPP technology, new innovative concepts and all, we are basically licensing. New reactor design, that's what, it is a totally natural, no power, no active system required, that fuel temperature, special fuel is there. So various technologies are available. Is it correct whether we continue to insist on EPR plan? If they are able to demonstrate with level 1 or level 2, level 3, this is what is basically being claimed. But how do you going to have a confidence unless we see those facilities operating and each and every of these things are demonstrated for their safety? DID, credit for advance and design in technology, and multi-module and multi-unit site. Fukushima, we have seen an external event causing event in this. So reasonable worst case scenario for which our preparedness has to be in place, and public perception and radiation risk. Ultimately, when it comes down to safety of the public, their awareness, their knowledge, their perception of the threat, their training is the most important. As long as they are able to take care of themselves, rest follow up by the district or responders at overall taking care of the society as a whole may be achievable. This is just a slide because I talked so much. What is the concern? Any release which is coming from the facility can give the exposure to the individual from various exposure pathway. That is a plume dose, inhalation, while he inhaling, if he is standing on the surface, ground deposited dose, resuspended of particles from the ground, food contaminations and all, and then corresponding emergency response actions which are required to be there. This is my last slide. That to strengthen all our framework is in place, we need to have an integrated emergency management system. Recent exercises we have seen that district authorities they are communicating among kind of a WhatsApp and all, they are well connected. But we need to have an integrated system for this where they can communicate. Assessment of plant damage state and real-time predictive source term. This is something, computing resource, AI, we should be in a position to come out where with confidence we can assess the deteriorating condition. Classification and then notification is the most important because this is the thing which gives you a time for taking appropriate response action in time. Decision support system, numerical weather predictions. We have seen how good nowadays weather forecasts are there, and subsequently field data assimilation and reconstruction of public doses. That is post-accident field data which is communicated needs to be used for reconstruction of this. So national redundant, reliable, secure communication network for communication, and post-cleanup operation and remediation. Your accident response does not stop in the early phase. Once it goes into the intermediate phase, you are having enough time, but then you need to take appropriate action based on that cleanup operations based on the measurement and reconstruction of the doses. I would like to thank my colleagues who helped in this preparation of this presentation and discussion. Thank you.